Hi boys and girls, this video today is going to be on lesson 6.5 and we're going to talk about sample size and sound conclusions. And what that really means is we are going to take some samples, meaning we're going to select things at random, and at random means you're just going to pick out of a total of something, and then we're going to use the information that we gathered from selecting a sample to help us predict basically what the outcome is going to be. Okay, so what you see bulleted here are going to be the basically the key skills we're going to be talking about. Of course, the first one, make predictions like we've been doing in science based on sampling. So based on what you pick when you draw something or pick one thing out of a bag, you're going to predict how many of that color are in the entire bag. We're going to be converting fractions to percents, which is something that we've done before. It'll be a review. And then finally also, we've done before, but it's part of our data, this unit, is to construct a circle graph or a percent circle graph from our data. Okay. So first let's look at what our activity is going to be. When you come tomorrow, you and a partner are going to be pulling basically counters, little plastic discs of all different colors and sizes from a bag at random. You're going to pull 10 times, and you can see I've made my virtual bag here with just different numbers of each color, yellow, green, red, blue, and purple. I believe the counters you will have tomorrow will be slightly different colors, but you and your partner will be pulling a random counter without looking 10 times. So you will have 10 pulls, and then you will record your results in fractional form. So let's go ahead and do that. Okay, so you can see that we virtually pulled from the bag. Now, do you notice that there are less marbles in the bag? Because we pulled some out, we've pulled 10 out. Now, I didn't look, I just pushed go, which is going to simulate when you and your partner reach in and pull out one counter at a time. So you can see from the table that we have here that when I did it, we pulled how many? Right? 10. You can see on the first pull, we got purple. The second pull, red. The third pull, yellow. The fourth pull, green. And then on the fifth pull, we got the same color we had already pulled. So remember, there are 5 different colors. We pulled the same color on our 5th time. Okay, 6th time we got blue. 7th, green. So green was pulled twice. 8th, red. 9th, yellow. And 10th, green. So you can see down here in this table our totals. We pulled blue once, green 3 times, yellow 3 times, red 2 times, and 1 purple. So think about it, boys and girls. How can this sample, okay, help us maybe predict how many of each color are in the bag? Okay, so think about it. There are 3 pulled of green, 3 pulled of yellow. So those are the most amount pulled. Do we think maybe, look at what was inside the bag, maybe are the most colors green and yellow? Maybe is that why? Could we predict that's why we pulled the most of this color? Okay, let's see what it says. So if we were looking at the probability, the blue was 1 of 10, or we'd record it as 1/10. 3 green ones out of 10 pulls is 3/10. 2 out of 10, 1/5. 1 out of 10, 1/10. Okay, that's our probability. If we want to think about the theoretical probability, that means if there's 5 different choices, we have a 1 in 5 chance of pulling any of those colors. Okay, so again, this is just an activity and you're going to be doing it, but when you have a random collection of colors, not planned, inside a bag, and you pull 10 at a time without looking, you'll record your results. Okay, right? So you can see that your results might be able to help you predict how many of each color were in the bag originally. Okay, all right, so tomorrow when you're doing it, you're going to take your data that you got when you pulled them out of the bag, the colors. You're going to change that from a fractional part into a percentage. Okay, so we're going to change it into a percent. Okay, so what would 2 or 1/10 be in percentage form? 1/10 would be 10%. Correct. What if we had 5? 5. That would be 50%. Correct. So we're going to be changing our data, our results, from the number of pulls in fraction form out of 10 total into percentage. Okay? After you collect your data, you're then going to be asked to create a circle graph or a percent circle. Okay? And every good graph, as you can see that I've already done with mine, contains a title. Okay? The number of colors, red, yellow, blue, green, purple, in our investigation virtually here. Yours, I think tomorrow will have white instead of purple. Okay? So we need to put our data into the circle graph. So let's go back and see how many red did we have. How many total red? 2. Correct. So we have 2 red, but that would be 100% of the graph. That's not all we have, correct? So right now it shows 100% because we're saying everything else has 0 data. So let's go to yellow. Yellow had 3. Now you notice how the circle graph changes. If our data was only for yellow and red, you see how it's just these 2 colors. More yellow was chosen, 3 than red. Okay, let's do blue. Blue was 1. Okay, it's changing again. Okay. We have purple is 1. So what do you notice about purple and blue? Yep, they're the same percentage. So their piece on the percent circle, the circle graph, should be equivalent. Okay. What do we have left to do? Green. Green had 3. Okay. So we've now inputted the numbers that we had out of 10, and we've turned it into a percentage. So 2 out of 10 is 20%. 3 out of 10 is 30%. 1 out of 10, 10%. 3 out of 10, 30%. And 1 out of 10, again, 10%. So you can see that now a circle graph represents that. Okay, now you should be able to analyze the data that you have in the circle graph. So what would you say is the maximum? Which one has the highest percentage? That's right, green and yellow, because they had the same number of pulls. Which one has the lowest percentage? That's right, purple and blue, they have the same. Okay. Right? So you can see we've made our circle graph into percentages based on the data that we took from pulling each one at a time and putting it out of 10 fractional parts. Okay? So in this lesson, we're talking about making a prediction based on sampling. So based on the samples that we just did here, okay, could you make a prediction about what was originally in this bag? Okay. So your prediction could be, I predict that there will be more of the green and the yellow marbles in the bag because out of 10 pulls, that was the most I got. But think about it, boys and girls. This bag only had, I don't know, a couple handfuls of marbles. Do you think we could make a better prediction if we had a bag full of 100 marbles? Yeah, we probably could. Our data might be more exact. Okay. All right. Our next one was converting fractions to percents. Okay. When we're doing it out of 10, that's pretty easy to take 1/10 or 5/10 and turn it into a percentage. Okay. But tomorrow it might be a bit harder. Okay. This should be a review. Also, constructing your circle graph. That's something that you're doing right now for your project, and it's something that we've done before. Make sure when you're doing your circle graph that you just check your percentages and make sure that it all adds up to 100%. Okay? All right, thanks, boys and girls. Good luck. Have fun tomorrow.